Hello, everybody. This is Louise Huffman. I'm going to be your hostess tonight. I'd like to welcome you to the Polar Educators International Masterclass Series, an introduction to Antarctic marine ecosystems. We're proud, whoops. Okay, I'm not going forward here, so hang on just a second. There we go. I think we've got the technology handled here. PEI is proud to have the support of partner endorsements and sponsors. We were created in 2012 in response to polar education momentum as a result of the IPY International Polar Year. And our funding sponsors have been ARCUS and CLIC. ARCUS is the Arctic Research Consortium of the US, and CLIC, Climate and the Cryosphere. We also recently have funding from the Antarctic Science Board. Our partners, the U.S. Ice Drilling Program Office, IASC and SCAR, and APEX, Early Career Scientists, and Gaia Antarctica, we all share common goals and work together. And we're really proud to have that international sponsorship and endorsement. PEI built a strong organizational structure, drawing on advisors and the institutional knowledge and experience and connections. Yeah, Gary?
Louise?
Yep.
We don't see your screen yet.
We're not seeing my screen. Oh, no. Let's see what.
I did start the recording, but we don't have your screen.
Okay, I think I'm in.
There we go.
Are you seeing it now?
Yes.
Okay.
Thanks.
Sorry about that. So our organizational structure looks something like this, and we draw on global advisors and focus advisors who bring lots of knowledge and experience to help us run this organization as a group of volunteers who are interested in polar research and polar science. We have lots of volunteers. Hope some of you will join us. PEI's mission is we're a vibrant network promoting polar education and research to a global community. And our vision is that Polar Educators International is a vital international network of educators and researchers aiming to provide a deeper understanding of current polar science. PEI represents trusted leaders working to inspire appreciation and knowledge of the polar regions, their connectedness to all Earth systems, and importance to all humans across latitudes and cultures. We have a strategic plan that has 5 goals, and each of those goals also has a working group working to reach those goals. And we would love to have some of you join us and pick an area that you're interested in and work with us. Just want to point out that we sponsor professional development throughout the world. We do international workshops, and we're integrally involved with the workshop in Norway and Montreal during the International Polar Year. And since then, PEI has sponsored a workshop in Portugal and Germany. And this spring, there'll be one in Italy. So there's still time to register for that, and we hope you'll join us there. We bring together scientists who are studying global change and climate change, and master educators to share information and how to transfer that knowledge to your classrooms. So it's my honor tonight to introduce our presenters. Dr. Jess Melbourne-Thomas is a marine ecologist with the Australian Antarctic Division and a project leader at the Antarctic Climate Ecosystems Cooperative Research Center. She's one of those exceptional people who's found a way to incorporate passions like scuba diving right into her work. She's formed a group called Women in Polar Science to help recognize the achievements of this under-recognized group. And she's also co-founded Homeward Bound and is the science program coordinator for that program. Betty Trummel is a veteran elementary classroom educator that I've had lots of experience working with, and I've enjoyed her collegiality and friendship. She's taught science methods at Northern Illinois University and spent 2 research seasons in Antarctica. This winter, she's heading back to Antarctica with Homeward Bound, the program that Jess is involved with. And I understand that some of you on the webinar tonight are also going on that trip, so welcome. Betty is on the PEI Executive Committee and the PEI Italy Workshop Planning Committee, as well as working on Masterclass Committee. So she's a busy lady. She's worked many years to bring scientists' voices to non-traditional audiences in schools and communities around the world. So welcome to you both, and thank you so much for giving your time to PEI's Masterclass series. With that, I'm going to turn the screen over to Jess, and it'll take just a second to do that. David and Gary, can you help me? Oh, there we go. Now we got it. Okay, Jess, you're up. You want to say something, and I think we'll just test your sound real quick.
Great. Hi, everybody. Can you hear me okay and see my screen?
Yep, you're all set.
Excellent. Thanks so much, Louise, and thank you for that introduction. Good morning or good evening to everyone, depending on what time zone you're in. I'm really excited to have the opportunity to present as part of this masterclass. So thank you to Betty and to Louise for providing that opportunity. And what I'm going to do is kind of over the next 30 minutes or so, just provide a general introduction to Antarctic marine ecosystems, including some current research on what we understand about the way that those systems are responding to environmental change and climate change in particular. Now, when we ran the practice, there was a little bit of a delay between me clicking the transition in my presentation and it showing up on your screen. So I'm going to just try and factor that in as I talk. But if you'll just have to forgive me if there's a few instances where I'm talking about something you haven't quite seen yet. So Louise gave a little bit of an introduction to the work that I do. I'm an ecosystem modeller with the Australian Antarctic Division and the Antarctic Climate and Ecosystems Cooperative Research Centre in Hobart, and my work focuses on developing and using computer models to make assessments about the current state of Antarctic marine ecosystems and the way that those systems might respond to change in the future. And then an important component of my work is around translating that information into policy and decision making. I do get a chance to go to Antarctica. This is me in 2013 taking a sea ice core to look at the algae growing inside the sea ice. I have interest and experience in other marine ecosystems as well. During my PhD, I worked on tropical coral reefs in Indonesia, the Philippines and Mexico, and I've also worked on temperate reef ecosystems. My only experience in the water in Antarctica was when I accidentally fell through a hole in the ice, and that was a very brief and very cold experience, but hopefully there might be others. So I've structured my presentation around a series of key questions, and the first of those is what's unique about Southern Ocean ecosystems. If you're interested and familiar with Antarctica, then you're probably aware that one of the things that's particularly unique is how isolated it is. It's isolated by the Southern Ocean and in particular the Antarctic circumpolar current, which circles in an eastward direction around the Southern Ocean. So in a polar context, generally Antarctica is really different from the Arctic in being a body of land and ice surrounded by water, as opposed to water and ice surrounded by land. And these physical barriers in the form of currents and also oceanic fronts have important implications for the biology of the Southern Ocean and are themselves responding to changes that we're seeing in the atmosphere. Another characteristic of Antarctica that makes it unique is that it's really highly seasonal. So we see a dramatic change in the portion of the Southern Ocean that's covered by seasonal sea ice between summer and winter. So during the winter, up to 18 million square kilometres of ocean is covered by sea ice, but by the end of summer, only about 3 million square kilometres of sea ice remains. And that seasonal cycle in sea ice and temperature is strongly linked to the biology and productivity. And this is an animation which hopefully is playing okay on all your screens. I'll replay it so you can see it a couple of times. This is an animation of remotely sensed, so satellite measured chlorophyll A in the Southern Ocean, and the red areas are where chlorophyll A or phytoplankton productivity is highest, and the blue areas it's lower, and you can see that white area, which is the sea ice, expanding in and out. We obviously can't sense what's underneath the sea ice from satellites, but you can see that we do get these areas of really intense productivity close to the coast when the sea ice is at a minimum during summer, and also in some of the oceanic areas. And so that primary productivity is what feeds productivity in the rest of the Antarctic food chain. Sea ice itself is also important in terms of primary productivity. This is a picture of a piece of sea ice that's been flipped over as the icebreaker ship moves through, and this brown mat on the underside of the ice is all algae, and that algae is available to animals that live underneath the ice during winter and is a really important food source. Antarctic biology is also unique, and one species that in particular characterises Southern Ocean marine ecosystems is Antarctic krill. We think that Antarctic krill make up an estimated biomass of 379 million tonnes, so that's by biomass more than that of the global population of humans, and of this over half is eaten by whales, seals, penguins, squid and fish each year, and then is replaced through reproduction and subsequent growth of the krill population. Krill can actually live for up to 8 years in aquariums, but in the wild they probably live for 3 to 4 years, and they spawn when they're 2 to 3 years old. An interesting feature of this species is that it forms really dense aggregations or super swarms, a bit like bait balls if you've seen pictures of them in other parts of the ocean, and those aggregations are important for feeding by species like baleen whales. And in this food web diagram to the right, you can see that Antarctic krill play a really central role in linking productivity from the base of the food web up through to higher trophic levels, penguins, seals and whales. So the second question on my list is around why these systems are important. What do we value about Southern Ocean and Southern Ocean ecosystems? And I thought I'd just briefly take a step back and address the question of what an ecosystem actually is. What do we mean when we talk about ecosystems? And we can think of them as being comprised of a series of components and the interactions between those components, and then the processes and functions that emerge. So in terms of components, you're probably familiar with the idea of species, with Antarctic krill being a really important one in the Southern Ocean. We have a range of different ways in which we can measure diversity. It could just be the number of species, but there are other concepts like genetic and functional diversity. Groups of species live together in communities, and this example here is of an Antarctic benthic community characterised by a whole bunch of filter feeding organisms like these worms that are capturing particles as they sink out of the water column. And finally, we have species and communities using a whole different range of habitats. And as I indicated earlier, one of the really important habitats in the Southern Ocean is Antarctic sea ice. And here's some penguins happily using that habitat. In terms of processes and functions, you might be familiar with the idea of energy pyramids that help us to visualise patterns of energy flow in ecosystems, from phytoplankton primary producers at the base of the food web up through to predators, and the pyramid shape is due to energy that's lost in each transition between trophic level. And then finally, nutrient cycling is another really important function performed by marine ecosystems. And this is a diagram that's showing some of the roles that larger animals can play in influencing nutrient cycling by moving nutrients up and down through the water column, by mixing and also releasing nutrients in poo. And we think that whale poo in particular might be an important source of nutrients, limiting nutrients like iron in the Southern Ocean. There are functions and values for Southern Ocean ecosystems, including fisheries for both krill and finfish, and I'll talk a little bit more later on about how those fisheries are managed. Conservation and biodiversity values, and also the roles that ecosystems play in sequestering carbon and so influencing the global carbon cycle and climate change. In terms of physical and chemical functions, one of the really critical roles that the Southern Ocean plays is as a heat sink and in carbon drawdown. So the global ocean absorbs about 25%, we think, of carbon dioxide that's added to the atmosphere each year, and the Southern Ocean then stores around 40% of this because colder waters are able to absorb more carbon dioxide than warmer waters. If you've come across acidification as a concept, that's a consequence of that increased drawdown of carbon dioxide, and I'll allude to that again a bit later. So in terms of the significance of Antarctica and the Southern Ocean on a global scale, it's right at the centre of this so-called thermohaline, or global overturning circulation, also gets referred to as the global ocean conveyor belt. So you can see in this diagram, the red represents the surface currents and blue is deep ocean currents, and we have these important processes of upwelling and downwelling happening close to Antarctica and also up in the North Atlantic. And hopefully it won't be too jittery on your screens, but there's a neat video from NASA of those patterns of circulation. And given the scales at which these processes are occurring, it's estimated that for the oldest waters in this pattern of overturning, it can be, in the order of 1,000 years for them to complete the cycle. I'll let that play for a little while, and it shows you that downwelling process happening up in the North Atlantic, and then the deep ocean currents returning to the south and circling around the Antarctic continent. So this thermohaline circulation is mainly triggered by the formation of deep water masses in the North Atlantic and the Southern Ocean, which is caused by differences in temperature and salinity of the water. And the next figure I have here is a different schematic that shows you a cross-section in which you can see the deep water coming up near the Antarctic continent and splitting back off into intermediate and mode water. And then importantly, this process of bottom water formation that occurs close to the continent and is driven by both the katabatic winds off the Antarctic continent and also the formation of sea ice and rejection of salt to form dense waters. So I'm going to take just a short detour right now to speak briefly about some notes on using graphics in presentations, and this is just an overarching theme. Betty's going to touch on it as well, I think, in her presentation. And these are just some of my thoughts on using effective graphics in presentations. And I'm inserting them now so that you have a bit of a chance to think about whether or not I'm following my own guidelines, and we'll come back to them again at the end. So for me, 3 important things are to try and keep graphics fairly simple, just demonstrating the key messages without too much clutter, not going too crazy on photos. It's easy with subject matter like Antarctic wildlife to go a bit crazy with photographs, but again, the principle of less is more can apply. And also I encourage people to experiment with new technologies and softwares. So the software that I'm using today is called Prezi. You might be familiar with it. And there are more new tools coming online all the time that offer really innovative ways to present your information. It's really worth having a play with some of those different tools.
And Jess,
so we'll go back to my list of questions now. And the third.
Jess, this is Louise. Let me just interrupt for 1 second while you're going back to your presentation. We would really like for the participants who are listening to be able to ask questions of you at the end. So if you have any questions as you're listening to Jess, go to the question box and just type it in, and then we will pose those to her when she's finished. Thanks for letting me interrupt.
No worries, Louise. Thanks, yes, and please do think of lots of questions to ask. So the third point on, in terms of my overarching questions are how are Antarctic marine systems responding to environmental change? And I've got a little bit in here on some of the physical changes that we're seeing as well. So one thing to note about Antarctica is that it provides us with this unique long-term perspective on global change, in particular through the kind of paleoclimate reconstructions that we get from Antarctic ice cores. And so there's a picture here of somebody taking an ice core from the Antarctic ice sheet. And there are a range of different ways in which we can get information from these cores, but a particularly important one is the gas bubbles that are trapped in the ice when it formed, and we can get these very long time series over thousands and thousands of years from analysing those gas bubbles. So this is a comparison here of historic atmospheric carbon dioxide concentration in red, and temperature proxy that comes from the ice cores, which is calculated based on the isotopic composition of oxygen in water molecules. This carbon dioxide concentration is coming directly from these gas bubbles, and that's been a really important source of information in terms of our understanding of the relationship between global carbon dioxide concentrations and local temperature. In terms of the primary drivers of ecosystem change, in an overarching sense, these include changes in temperature, wind, the process of acidification that results from increased dissolution of carbon dioxide in ocean waters, and also harvesting of marine species. But the relative importance of these drivers varies depending on what region we're talking about. And so this schematic here is a cross-section from subantarctic islands in the north through to the sea ice zone in the south. And so in these different habitats we see different processes being important for key species. Around subantarctic islands, species like elephant seals and penguins are dependent on oceanographic features like eddies and ocean fronts for feeding, and as these features change there are consequences for those species. In the pelagic zone, it's things like acidification and changes in the vertical structure of the water column that are important. And then in the sea ice zone, we are seeing some changes in seasonal patterns in sea ice and associated productivity, but the picture certainly isn't straightforward, and so I've got a little bit more detail on sea ice in my next slides. So just to be very clear, there is a difference between Antarctic sea ice and ice shelves. And I've got a graphic here that shows that difference. So sea ice is seasonal in its formation and melt. We see formation of sea ice close to the continent and also through freezing over the ocean. But it's like a crust that can be up to several meters thick that advances and recedes every winter and summer. The ice shelves are the ice sheet flowing down off the continent, and that's where we get icebergs. We also have intrusions of water underneath ice shelves, and in recent years we've started to see accelerated disintegration of ice shelves in various parts of Antarctica, which we think is because more warm water is getting underneath these ice shelves. And just to give you a sense of the importance of those processes, there's a voyage that's just departed from the Australian Antarctic Division and the Antarctic Climate and Ecosystems, CRC, which is headed to look in more detail at some of the processes around the Totten Glacier in East Antarctica, and it's estimated that if that ice shelf were to collapse, we'd see 3 meters of global sea level rise. So we're talking very significant volumes of ice. In terms of the changes that we're seeing in sea ice habitats, overall at the circumpolar scale we've actually seen a slight increase in sea ice extent, which is in contrast to the dramatic decrease in extent that we've seen in the Arctic, and there's probably various processes driving that slight increase in extent, but it's a complicated story and has implications for biology. Similarly for duration, we've seen slight increases in the sea ice season in some areas and decreases in others, and I've got an image of that I'll zoom into in a moment. But the two big question marks are around sea ice thickness and volume, because those are two variables that we're not currently able to measure using satellites. And it could be that's where quite dramatic changes in the sea ice are occurring. So this is a figure from a recent paper which is showing the change in the number of ice-covered days per year. The purple and blue colours are decreases in the number of ice-covered days per year, and the red and yellow are increases. And so in the Antarctic Peninsula region, you might be familiar with the rapid pace of change there and decreases in sea ice that have implications for penguin populations, whereas in other regions we're actually seeing longer sea ice seasons, which can have implications for things like fishing and tourist and research vessels trying to access the coast. A particular focus of my area of research, as I said, is in using models to try to understand how these changes in the physical environment might affect biology into the future. And this is an example from some recent work using output from a sea ice model to evaluate changes in habitat availability for larval krill. So here we have just a simplified version of the Antarctic krill life cycle, showing that this larval stage is dependent on habitats underneath the sea ice during winter, and larval krill are eating algae that's growing underneath the sea ice, and they also use crevices on the underside of the ice to escape from some of the strong water currents that flow underneath the ice. So in these images on the right, the orange and red areas are where we identified habitat that might be suitable for larval krill during winter, and the red colours indicate a high degree of suitability. This is for the month of August under a current climate up the top and under a warm climate scenario down the bottom. And the key result here is that we actually saw an increase in our area of predicted habitat under the warm climate scenario. And that's surprising because many of the predictions that we have available for the effects of climate change on Antarctic krill indicate there'll be negative impacts for the population. And these results just demonstrate that often our predictions are fairly complicated for biology, particularly when we have these different life cycle stages as we do for krill. So I'll finish up then by just talking briefly about how we might respond to these changes, both in a management sense and also in terms of our overarching focus questions for research. The Southern Ocean, conservation in the Southern Ocean is managed through a range of different bodies. They all get their own acronym. CAMLAR is the Commission for the Conservation of Antarctic Marine Living Resources, International Whaling Commission. We have the Committee for Environmental Protection and also the Agreement on the Conservation of Albatrosses and Petrels. So all of those bodies play a role in terms of managing Southern Ocean ecosystems. CAMLAR is unique in that it takes an ecosystem-based approach to management, which attempts to implement management strategies that factor in responses of dependent species as well as target species. And I'll give you an example for Antarctic krill in just a minute. Two overall challenges for management in the Southern Ocean and also in marine systems more generally are how do we detect change and respond in a timely way before the changes that we're seeing really become a problem, and how do we deal with ecological surprises. And there's lots of evidence from other marine systems that we do get these really dramatic transitions in the fundamental state of ecosystems. You might be familiar with the kind of changes that occur on coral reefs, or the transition from kelp forests to urchin barrens on temperate reefs, and we're not sure whether those kinds of transitions, really dramatic transitions, are possible for the Southern Ocean. So in CAMLR, a lot of recent work related to management of the krill fishery has been towards developing what's called a feedback management strategy. So the figures on the left there show you patterns of change in the Antarctic krill fishery from the 1980s through to the current pattern of the fishery. In the 1980s, there was a circumpolar distribution of the fishery, but more recently we've seen the fishery become highly concentrated around the Antarctic Peninsula region, with much larger catches being taken in concentrated areas. And so there's some concern around the effect that that might have on predators that are dependent on krill, penguins, seals and whales. As an interim measure, CAMLR's implemented this distribution of catch across different sub-areas, but that's intended as an interim measure while strategies are developed. And so those strategies will be designed to incorporate monitoring data from penguins and seals to try to adjust catches in a dynamic way, and so avoid undue impacts of fishing on the rest of the ecosystem. And that's quite unique in terms of a management strategy on global scales. And then you might have seen recently in the news some significant success and progress in CAMLR in implementing what is now the world's largest marine protected area in the Ross Sea, 1.5 million square kilometres of different zoning, and that's a very significant achievement in an organisation like CAMLR that's based around consensus, and hopefully paves the way for the development and designation of other marine protected areas in other regions. And then finally, the big questions and current work for us in terms of the science that underlies that decision making is in an environment like the Southern Ocean that's really expensive to observe and travel to. How do we strategically design our research to make the most of information? What do we measure, and how do we make it meaningful? What are the clearest signals that we can derive regarding change in ecosystems, and how can we build them into our management frameworks? And from my perspective, ecosystem modelling is a really critical tool in that work. So that's it in terms of those overarching questions. As I said, I'll just briefly touch again on the sideline around using graphics, and I just wanted to finish up with my little plug around saying no to death by PowerPoint. I think we're well and truly past the age of PowerPoint, so I implore you to please go away and try other tools. And with that, I will say thank you and pass back to Louise and Betty.
Thank you so much, Jess. That was great. We have a couple of questions, and let me pose these to you. One of them was asked earlier, and you may have answered this well enough, but I'm going to ask it anyway if you have anything you want to add to it. The question was, krill are a keystone species in the Antarctica ecosystem, so any changes in krill population size could have significant impacts on other species in the ecosystem. How are the krill doing, and has climate change had negative impacts on the krill? So I know you talked some about that, and just wondering if there's anything else you'd want to add to that question.
Yeah, it's a really good question, and it's one that's really fundamental to a lot of the research that's happening around Southern Ocean ecosystems. One of the things we don't understand all that well is the importance of alternative energy pathways in food webs. So we think that in some regions and at some times of year and possibly in the past, fish and other crustaceans, apart from krill, have been really important food sources for a lot of predators. But it's possible that those food sources can't sustain as many predators as krill do, and so we've had some recent voyages in East Antarctica, and there's certainly a lot of work in other areas as well, trying to understand the relative importance of these other food sources, and then as whoever asked that question rightfully said, understanding what the population changes for krill are, and certainly in terms of adult krill, climate change is likely to have negative impacts on their development and also on food sources, but we're less sure for some of these other life stages.
Okay, great. Thank you. There's a couple more. Couple people really like the cartoon diagrams that you had, especially the Southern Ocean one, and I like the one with the water and the different layers in the water. And they're wondering if they could get access to those diagrams for use in their presentations.
Yeah, sure. Yes, I can provide perhaps a list to you, Louise, of the sources for some of those so that people can go away and find them from the sources, and for ones that might not be available, I can perhaps just provide the figures themselves. I'm happy to do that.
Okay. And then let's see, the last question was, I think there might be a word missing, but let me ask it. With the changes in the physical causing changes in krill populations, also change the life cycle timeline for the krill, thus affecting the populations that feed on krill. So I'm not sure. I may be missing some words in this question that I'm reading. Does that? Oops.
Sorry, I lost audio completely then. Could you ask that again? It just all broke up.
Okay, can you hear me now?
Yes.
Okay. I think there might be a word or two missing in the question, so I'm going to read it and see if you can figure out exactly what I'm trying to say. With the changes in the physical causing changes in krill populations, also change the life cycle timeline for the krill, thus affecting the populations that feed on the krill?
Yeah, I think that's probably a question around the term we use in ecosystem science is phenology, so that the timing at which important biological events happen, and that's really critical not just for krill but for a whole range of other species, given that things like penguins come on land to breed at particular times of year, and if their normal food sources aren't available at that time because of shifts in the timing of other biological processes, that can have really significant consequences across the ecosystem. So yeah, there's a lot of work happening in that space, and it's not just the changes themselves, but it's how those changes affect the overlap of different biological processes.
Great. Thank you so much. And to the audience, continue to add questions if you think of them, and we will pose them. And if we run out of time at the end, we will put them in the discussion group. So Betty, I'm going to turn the screen over to you now. And again, thanks, Jess.
No worries.
Okay, can you see that, Louise?
I'm not seeing your screen yet. I hear you. There we go.
I am.
Okay, we got you now.
I can see it.
Yep.
Okay. Whoop, wait, hold on. Okay, well, Jess, here is death by PowerPoint. Actually, PowerPoint works very well on the GoToWebinar platform, but I agree with Jess that you need to try different platforms for different presentations and different audiences. My name is Betty Trummel, as introduced me previously, and I taught for 35 years in an elementary school setting, and also taught science methods at Northern Illinois University for 10 years. And I've had the opportunities 3 to Antarctica and work with scientists. And I think to get started, I'm going to show and share my pathway a little bit with you in how I became a polar educator and what that meant to me as a classroom teacher, and also how I continue to make an impact working with scientists right now. Oh, hold on, now it's not going. There we go. So my 3 Antarctic deployments started back in 1998. I've been part of education outreach teams, integrating science and research along with education, kind of being the eyes and the ears of scientists as they're working and communicating that not only to students and teachers, but also to a broader educational community and just the general public. So the first experience was called Teachers Experiencing Antarctica and the Arctic. We call it the TEA program. And back in '98, I was randomly assigned to the Cape Roberts project, which was a geologic drilling project taking place in the McMurdo area. So I was there for about 6 weeks as part of the project, and I'll show you what that looked like. The second opportunity was ANDRIL, Antarctic Drilling. That was in 2006. And the third experience was WIZARD, which stands for Woolens Ice Stream Subglacial Access Research Drilling. As Jess mentioned, there are a lot of acronyms around Antarctic science. And I'll explain what those projects were all about. All 3 of the projects were supported by grants from NSF, the National Science Foundation. And that's important because they put their money into having teachers go down and communicate the science with the public, and also we have people supporting us from various institutions and universities. So the goals for the education outreach were pretty much the same for all 3 programs, to immerse the teachers in this research experience as part of our own professional development. And that would help us inform teaching practice through research experiences. They wanted us to bring polar research into classrooms in new ways, innovative, engaging ways, not only before the experience, but also throughout the experience and post-ice experience. We were required to do ongoing communication with students, educators, everybody around the world through blogs, photographs, videos, video conferencing, interviewing people, and so much more. And you'll see how that's really changed since 1998, when I first went down to Antarctica. We wanted to expand this polar learning community, and that's one thing that PEI is working to do every single day. We're trying to bring on more teachers and more researchers and expand that polar learning community, sharing resources together to connect scientists and educators and to inform everybody about how to best communicate ongoing science research. We want to also encourage educational outreach activities to reach learners of all ages. Today I was at a high school talking to environmental science class, and in a couple weeks I'm going to Sun City, a retirement community. There are learners out there of all ages that want to keep learning throughout their lifetime. One of my personal goals has always I developed a traveling trunk of teaching materials, so videos, stuffed animals, posters, photos, all kinds of things that could teach others around Illinois about the polar regions. Oops. Why is that not going? Hold on one second. A little glitch. Okay, oops. Okay, so those experiences expanded my own professional development community, and I met a guy, Gordon Bain, who actually worked for the Australian Antarctic Division where Jess is now, but this was years ago, back in 2000, 2001. And we created a sister states kind of a loan of the same kind of trunk of materials. I gifted it to the teachers of Tasmania through another grant from Delta Kappa Gamma. I traveled to Tasmania, and Gordon and I went all over Tassie and did presentations, dressing kids up in outfits and talking about both of our experiences in Antarctica. Meanwhile, he put me in touch with an author, Carl Tulloch, who writes not only fiction but nonfiction books about Antarctica and the polar regions. And we actually brought both Gordon and Coral to the U.S., to my school district, and had them spend each about 2 weeks with students. Coral was doing writing and drawing, illustration with the students, and Gordon was talking about all of his experiences on the Aurora Australis as part of the Antarctic Division. So it broadened my own community and my own professional development. Andro was a bit different. This was a huge multinational project, like Cape Roberts in that regard, but unlike Cape Roberts, because I was the only teacher involved with Cape Roberts communicating the science, Andro had a teacher from New Zealand, one from Germany, one from Italy, and 3 teachers from the US. And the goal of Andro, which stands for Antarctic Drilling, they set up a drilling platform the season I was there on the McMurdo ice shelf, and they melted through the ice, went through the water column, and retrieved sediment samples from the sea floor. Most of us were based in McMurdo Station, which is kind of like a small Alaska mining town you can see in the upper left, and the logistics guys in terms of the drilling and the core technicians were based at Scott Base, which is a New Zealand base very close to McMurdo Station. If you look at that map, we were on the very tip. Scott Base and McMurdo are right next to each other. We were at the very tip of the Hut Point Peninsula, and you can see McMurdo Ice Shelf. That was the season I was there in the round circle, and then the drilling was moved to a different location the following year. So this immersion, this annual research immersion for science educators, they call this the Arise Teachers. This brought a whole new component to the project in terms of sharing materials, sharing ideas, learning from one another. Luann, for example, one of the US teachers, she developed a wonderful Flexibit package of flexible materials that can be used to put on a science event in your school or in an informal education setting. And I use that with my students for years after Andro. Vanessa taught in New York City, so I'm in a suburb of Chicago, very suburban. She was right in the city. So we had a lot of really different kinds of teaching experiences. Julian was at a high school in New Zealand. Alexander is still at Heidelberg University in Germany. And Matteo and I became fast friends. And you'll see how that cooperation has continued for the past 10 years. He teaches high school in Rovereto, Italy. And he and I are putting together, along with a lot of help from other PEI members, the workshop that's going to be in Rovereto, his hometown, next April. So maybe you could join us at that. We had daily meetings with the different educators, with the science teams. We could pose our own questions and get new information, not only on geology, but about Andro. It was a great way to collaborate with the scientists. And they were eager to get their information out to others, and something that they're not always really skilled at. They don't get training in that necessarily, but we were kind of helping each other realize some very important goals. Every day I did take part in the scientific work for Andro. That was a big part of my day, and then there was communication that went along with that. Matteo designed this model about what the Arise teacher actually did and how many different groups of people we actually influenced or worked with. The red arrow represents our work with the scientists. So that was a key part of this whole equation. the teachers working with the scientists, working alongside them, learning about their science, and then communicating that back to students. I love the students, a little angel and devil. You've got teachers, school administrators that evidently all look like Elvis Presley, families, museums, and other institutions, and also heavily involved with the media. What Matteo and I realized, and we, like I said, we became friends almost immediately. We're very much the same in terms of the way we teach and how we view students being active in their learning. We found this parallel development of our own projects, but that gave us a new dimension to this Andrew Larise connection. We found that we could give each other mutual and constant support in whatever we were doing in terms of communication, projects, or activities. You're going to see how that played out just recently. We also found this multilingual and multicultural perspective. So looking at things being translated, PEI has a lot of materials that have been translated, as does Andril. If you go to the Andril website, andril.org, there's a great education section on that website, and Louise was the education outreach coordinator for Andril. We also have figured out a better way to organize our own professional development events. For example, Matteo came to the National Science Teachers Convention and presented with me in the US. He also came to my classroom and worked with my students. And I've been in his classroom and been at different activities and events with him. So not only were we sharing what the scientists were doing, but everybody kept asking, well, how do they get the core? How does the drilling work? So I took it way back to the very beginning of the project to show everybody how the drilling took place and how the scientists actually got the cores that they were working with. Because that's a great example of STEM. You've got all kinds of technology and scientists working together to use that technology to get what they need to conduct their science. So the scientists were focused on looking at the samples that were retrieved in that drilling process. So we examined about 1,200 meters of core the season that I was there. That came through the Crary Laboratory. Wizard was a bit different. Again, it was a smaller outreach team. Susan Kelly was the coordinator, and I was representing two scientists here from Northern Illinois University. And this was not as international in focus, although we did have some international guest scientists on the project. The goal of Wizard was to set up a hot water drilling platform and drilling system on top of the ice sheet and melt through the ice sheet and have access, clean access, to a subglacial lake called Lake Willans. And that was achieved after a lot of delays and a lot of frustrating things. It was actually achieved, and it was quite a success story in terms of science and technology. And that picture on the bottom right shows Ross Powell. Dr. Powell was one of the co-chief scientists for Andril. He also worked on Cape Roberts and was a co-chief scientist for Wizard. And then Reed Shear worked on all three of the projects that I've been on as well. One of the coolest things is to keep working with some of these teachers that I've met. And I had the chance this summer to work with Matteo and his students on, on a project called RESET, Research and Education Svalbard Experience. Matteo and his students spent 2 years raising over 35,000 euros to make this project come true. So he really gave them skills far beyond the science that they were learning and far beyond the walls of their classroom. He showed them leadership, entrepreneurism, gave them confidence to carry out this project, and 20 of the 22 students in this RESET project were girls. And the whole goal of us going to Svalbard was to further their science education, their knowledge on climate change, learning about the flora, fauna, glaciers, permafrost, and also the cultural and historical perspectives of Arctic Svalbard. And all of that was achieved and more in this 10-day expedition. And I've got to say, we did a lot of hiking and a lot of backpacking, and it was the hardest backpacking I've ever done. Up and down fjords, crossing on ladders across these glacial rivers, and it was incredible to see these students in action. We were all learning together about this Arctic environment through this real-life experience that was designed to involve the students in every single aspect. We had students giving live radio broadcasts on Italian radio up in Svalbard. We had students collecting data and information and photographs and sounds everywhere we went, all over that Svalbard region. And if you look at this picture, it shows Matteo and I in the upper right, back as part of the Andro project, when we just had met each other, and then below, holding a PEI sign up in Svalbard this past July. We know that collaboration is a key element in both of our ongoing professional development, professional lives. And without it, I think we know we'd be missing a lot. And that's where PEI really plays an important role. PEI fosters this networking and fosters important collaborations between scientists and educators, and among educators themselves. So I know we have both scientists and educators on this webinar tonight, and I'm glad to see that both sides take an interest in this whole idea of science communication and sharing our work on both ends of the equation. As Louise hinted to at the beginning, I'll be one of the participants in Homeward Bound that Jess is one of the co-founders of. It's a leadership and strategic program for 78 women in science from around the globe. And these women they range in age from 24 to 60. I'm on the 60 part of the equation. And we'll be departing from Ushuaia, Argentina in now a little bit less than a month. And we'll be on a 20-day expedition, a leadership and strategic expedition, also taking field trips, learning about elevating the role of women in leadership globally, demonstrating how polar science tells us what's happening with the planet, and looking at how women at the leadership table might give us more of a sustainable future. So let's talk for a minute about some resources that you can use that can kind of transfer Jess's science and information to classrooms of many different ages. Before I ever met Jess, and I actually have never met her in person. I've only been Skyping with her and talking with her through Homeward Bound and on our own. But before I met Jess, through Gordon, I found out about these wonderful resources from the Australian Antarctic Division. And they have this program called Who's Eating Who? And you can access that through their website, antarctica.gov.au, and through their education portal. And one of the things I want to share with you is this mystery, an Antarctic and Southern Ocean mystery about the sudden disappearance of huge numbers of krill. And you're going to learn about the food web and environmental sustainability. So taking some of the things that Jess was talking about in terms of the krill and looking at a way you can transfer some of that information to classrooms. So in this Who's Eating Who package, I'm just going to show you a few of the materials. It's a really cleverly written story with gorgeous graphics. Jess talked about using graphics in her talk, and I want to reiterate that good graphics can really speak volumes. This actually sets the stage for the investigation. So I know you can't read all the text on the left, it's quite small, but you can see how there are graphics interspersed with text, and then you've got different pages. The one on the right is called Slippery Characters, but you also have feathered fiends or feathered friends. So penguins, you've got low-life forms like phytoplankton. The flying squad is everything from storm petrels to albatross. You've got the slippery characters were the seals, and the Mr. Bigs are the whales. So all of those have beautiful pages with information that you can use in your classrooms. They also include not just this food web, but there are other resources and lesson plans I suggest, and I'm going to put some of these into our discussion group as we talk the next couple of weeks about this masterclass and the information. I'll be putting some resources into that discussion group. I've already uploaded, or it should be uploaded, a PowerPoint on the ocean food web and food chains that Jess shared with me, and also some other resources and lessons. So all of this background information leads to one activity that I'd like to share that has to do with building an Antarctic food web and taking a look at factors that can actually impact the food web. This is actually one of the slides that's in the PowerPoint. I wanted to put one up so you could see a really good example of the different flow of energy between things in the food web. And this is by no means comprehensive. It's just one bit of information that you can access. So in this activity, you're going to see these different components: the fishing boat, killer whale, humpback whale, everything from albatross and leopard seal, squid, toothfish, emperor penguin, Weddell seal, krill, and phytoplankton. Those are all the players in our game that's called Catch-a-Catch. And so you've got all of those critters that are a part of the game, and it's pretty simple in terms of what you need to get in terms of resources. It really involves some ropes and possibly some picture cards or name cards. When I've done this activity, not with an ocean ecosystem, but with a forest or a prairie ecosystem, I've used either name cards or picture cards that have names on them. And with younger students, I've actually even put information about each animal on the back of the card, so the student reads up on their animal before the game begins. So each student is assigned one animal in the food web, and once they have their designated animal, you're going to join the ropes together according to the description below. So for a thick green rope, it'll be the phytoplankton to the krill. And I suggest you use a clothesline that you can cover, or some other kind of twine or rope. You can cover that with colored duct tape or bits of cloth that you tape around or you wrap around the rope. You'll have a green and white rope that connects the krill to the squid, fish, emperor penguin, seal, humpback whale, and the albatross. Then you have a yellow and black rope, a white rope, and an orange rope as well. So this will all be in the archive of the masterclass. And actually, if you want me to post some of that in the discussion group in the next couple of weeks, I can actually post a little bit of my PowerPoint for you, and then you have that as a resource in your classroom. Sorry, I needed a drink of water. Okay, so the action part of this is, what are the impacts that can happen to the food chain and the ecosystem in the Southern Ocean? So if someone that has krill shakes the line because it's impacted by overfishing, who can feel that when the krill shakes the rope? Who can't feel it? If you can feel it, shake the rope as well, and now it starts to impact so many other components of this food web. You can show another impact on the ecosystem, such as maybe the loss of phytoplankton due to global warming. So students who are affected can drop their line, and you can have more than one student be krill or phytoplankton because those are more abundant in the Southern Ocean. And if someone has a connecting line, they drop it as well. And so you start to see how all of these things are interconnected, and what happens when we impact one part of that food web, it affects all of the parts of the food web. And so then you want to talk about those various links in the food web and what's going to happen if individual links are affected. Are some things going to be more overpopulated? Are some things going to be endangered or possibly extinct? So what would happen to this ecosystem? So in conclusion, what I'd like to say is that being a part of Androl and Cape Roberts and Wizard and Reset, and particularly for me, Polar Educators International, is really important. I might be retired from classroom teaching, but I'm finding ways to still do a lot of education and outreach. And places like the PEI website and our organization really keeps us alive for scientists and educators around the world. And we want more of you to be active in PEI and help us keep spreading the word about polar resources and polar science education. So, any questions? Louise, are you there?
Yeah, I just came back on. Sorry. Yeah, we don't have any questions in the question box right now. So what I'd like to do is I'm going to take the screen back. So hang on one second. Okay. Betty, are you seeing my screen? Because I see you have audio.
Oops, hold on. Let me minimize mine. Yes, your screen is back.
Okay, so just wanted to thank all of you for being here tonight, and especially thanking Jess and Betty for presenting and sharing their time with us. There will be a discussion group that's going to start Sunday night. It'll be Sunday night in the US and I think Monday morning in Australia, polareducator.org. And by being on this webinar, I believe you had to join PEI. So if you just go to the educators tab and click on members area, and then you'll log in. If the first time you log into the members area, you'll set up a username and password. And just from experience, there's a little box under username and password that says, remember me. Always check that box, because for some reason this Joomla social website wants to log you out repeatedly. So check that remember me and it'll keep you logged in. We'd like to ask you to join in the discussion. There'll be a new question posted each week, and the resources can be posted there. So if you want the directions for the krill game and things like that, they'll be posted there. You can ask Jess and Betty questions, and we can share with each other ideas for teaching food webs. I'm sure a lot of you have done some of these things and have some great ideas. So it'll be a really nice way to share ideas. At the completion of the syllabus requirements, you'll receive a certificate of participation. And the syllabus is posted on the website. So we also want to be sure to thank our sponsor, Click. Climate and the Cryosphere, we couldn't do this without them because they provide us with website support, conferencing, and webinar capabilities. So big shout out to Click. And then just want to remind you that the Italy workshop is coming up in April. It's going to be great. We have a lot of scientists who are going to be speaking live, and lots of classroom activities for you. And you'll see Can Switzerland Be Far Behind? Polar 2018 is going to be in Switzerland, and PEI is working to have a presence there. So we'd love to have you join us. So thank you, everybody, for being there. Thank you, Betty and Jess, and good night or good morning, wherever you are in the world. Thank you.
Thanks, Louise.
Thank you, Jess.
Thank you, everyone.
No, I turned it.
Still shows